Hello everyone, welcome to the channel StatisticaHub. So we are discussing IITJAM 2023 question paper, and we have done 14 questions in the previous lectures. Let's continue with the question number 15. Okay, let's see it. What is in the question number 15? So it is given that let x1, x2 to xn be a random sample from a population having the probability density function like this. For estimating mu, consider estimators T1 and T2, where x bar is equals to 1 by n sigma xi and x1 is minimum of x1, x2 to xn. Then which one of the following statements is true? Check for consistency of both the estimators. Okay, so what is in the options is we have to check for the consistency. So whether these two estimators are consistent or not. Okay. So let's check for that. So before doing this question, you have to know that what is an consistent estimator. Okay, what is an consistent estimator? So an estimator, let's say T, based on a random sample x1, x2 to xn, is said to be consistent to gamma theta if T converges with the probability P to gamma theta as n tend to infinity, right? That's what we have studied for the consistent estimator. We will apply this concept in this question. Okay, now let's just look at the PDF, that is 1 by 2 e's power minus x minus 2 mu upon 2. Now I am getting the idea from here. It is the PDF for 2 parameter exponential. Okay, it is the PDF for 2 parameter exponential. And what is the PDF for this? That is 1 by beta e's power minus x minus mu by beta. This is the PDF for 2 parameter exponential. Okay, where mu is my location parameter and beta is my scale parameter. Okay, let's just replace it by alpha. Okay, now what is the mean for this 2 parameter exponential? That is alpha plus beta, right? Let's just apply it in the similar way here. That here my alpha will be equals to 2 mu. Okay, and my beta is equals to 2, right? So my mean for this part is expectation of x is equals to 2 mu plus 2, right? Okay. Now let's just look at these consistent estimators, that is T1 and T2. Okay, so for this to be convergent to some gamma theta with the probability P, what we have to do is my T1 is equals to x bar minus 2 by 2. Converging with the probability P to what? So for that we have to find the expectation of T1. So what we are doing is we are applying weak law of large number. Okay, let's just find out what is the expectation of T1. That is expectation of x bar minus 2 by 2. That will be equals to 1 by 2 expectation of x bar. What is expectation of x bar? Expectation of x bar would be equal to expectation of 1 by n sigma xi, that is equals to 1 by n into sigma into expectation of xi, and that will be equals to 1 by n 2 mu plus 2. So my expectation of x bar would be equals to 2 mu plus 2. Okay, you just don't need to calculate this, because if you do more problems, so it is understood that expectation of x and expectation of x bar would remain same in this part. Okay, so expectation of x bar would be equals to 2 mu plus 2 and expectation of 2 would remain 2. Okay, so this will cancel out and we got expectation of T1 is equals to mu, right? So what we are getting by the weak law of large number, that T1 with the probability P is converging to mu as n tend to infinity. Okay, so it is an consistent estimator. Consistent estimator, right? Right. Now let's check for the another estimator, that is T2. What is my another estimator? That is T2 is equals to n x of 1 minus 2 upon 2n, where x1 is minimum of x1, x2 to xn. Okay, now for this part, we'll use MLE because it will be like very simple by using MLE. So what will be the MLE here? MLE of mu. The MLE of mu. So for finding the MLE, as we can see that x here is depending on the parameter. So whenever the x is depending on the parameter, we'll use order statistics, that is like 2 mu less than x1, x2 to xn, right? We do it like this. So from this we can see that mu is x less than x1 by 2. So my MLE for mu is equals to x1 by 2, or you can also say that MLE of 2 mu is equals to x1, right? So let's apply it here, and we know that MLE is an consistent estimator, right? So by using this, we have T2 that is equals to nx1 minus 2 upon 2n with the probability P. Let's just find this expectation of T2, and this expectation of T2 would be equals to n. What is expectation of x1? Expectation of x1, like it is in consistent estimator, MLE is in consistent estimator. So what will be my x1? That is equals to 2 mu, right? 2 mu minus 2 upon 2n, and this would give me, like, let's just write it here, mu minus 2 by n. Okay, and we are checking this as n tend to infinity. Okay, so as n tend to infinity, 1 by infinity is going to 0, so this will go to 0, and I got this T2 is equals to mu. So we got expectation of T2 is equals to mu, as T2 is converging with the probability P to mu as n tend to infinity. So it is also a consistent estimator. Okay. Okay. So we got T1 and T2 both are consistent estimators for this PDF. Okay. Let's do question number 16. What is in this? Okay, so in the question number 16, it is given that let an be a sequence such that a1 is equals to 1 and 4an plus 1 is equals to root of 45 plus 16an. N is equals to 1, 2, 3, and then which of the one of the following statements is true? Whether it is bounded above by this one, it is convergent, converges, monotonically increasing. Okay, so we have just checked for the monotonically increasing, whether it is decreasing function or increasing function. So we have a1 that is equals to 1, and if we put n is equals to 1 here, we will got our a2. So 4a2 is equals to root 45 plus 16 a1, and a1 is 1, so we will got plus 16. So a2 is equals to root of, this will be 61 by 4, and this value I think is greater than 1. Okay, this value is greater than 1. So from this we can see that this sequence is a monotonically increasing sequence. Okay, so this is a monotonically increasing sequence. Okay, and we know if we want to find the convergence of this whether for which value this will converge. So for this we know that limit n tend to infinity of an will converge to the L limit, and limit n tend to infinity of an plus 1 would also converge to the limit L for n tend to infinity. Okay, so they will both converge to the same limit. By applying this concept, as an plus 1 would converge to L and an would also converge to L, so by using this, 4L is equals to root of 45 plus 16L. Okay, that is equals to 16L square is equals to 45 plus 16L. So it's just a simple quadratic equation. You just have to solve a quadratic equation, which is 16L square minus 16L minus 45 is equals to 0. 16L square, what will be the this function? That is, I think, 36 minus 20. L minus 45 is equals to 0. That is 16L square minus 36L plus 20L minus 45 is equals to 0. Taking out common 4L, we will get 4L minus 9 plus 5, 4L minus 9 is equals to 0. So we will we have got two roots, that is 4l minus 9 and 4l plus 5. Okay, so my first L is equals to 9 by 4 and other is minus 5 by 4, and we know that it is an increasing function and the minimum value it is taking is 1, so the limit L can't be negative. So my limit L is equals to 9 by 4. That is, an is monotonically increasing function and converges to 9 by 4. So this option number 4th is correct. Okay, so this is a pretty easy question. What do you have to do is simply look at the question, what is it asking, and just simply use similar some very small concepts of limits. Okay, you just have to know this part, that an plus 1 would converge to the same limit. Okay, and just solve the quadratic equation and you'll get your answer. Okay, let's just look at another question number 17. Okay, so in the question number 17, it is given that let x1, x2, x3, x4 be a random sample of size 4. Okay, so we have given here that n is equals to 4 from normal theta comma 1 distribution where theta is an unknown parameter. Let x bar is equals to 1 by 4 sigma xi and g theta is equals to theta square plus 2 theta. And L theta be the Kramer-Rao lower bound on variance of unbiased estimators of g theta. Right. Okay. So L theta here is my Kramer-Rao lower bound. Then which one of the following statements is true? Okay, so we have to check for these four statements that which one of the following statement is false. Sorry. We have to check for the wrong statement. Okay, so let's just find out that what is the CRLB first. What is the Kramer-Rao lower bound for this G theta estimator? Okay, so for this, what is my CRLB Kramer-Rao lower bound for G theta? Okay, so if you don't know the Kramer-Rao lower bound, then you won't be able to do this question. You have to know this formula for doing this question. That is G d dash theta's whole square upon I theta, where I theta is the information on theta, right? Okay, so what is my g dash theta? Differentiation with respect to theta for this function, that is 2 theta plus 2, right? And let's just find out I theta. So there are so many formulas, like I think 4 formulas, not so many, for the I theta. So we will apply this one, that is minus expectation of del square by del theta square log L. Okay, so I theta for the normal distribution theta comma 1, like theta comma sigma square is basically sigma n by sigma square, sorry, n by sigma square. It's just like we when we do like more problems, we just memorize some results. Okay, so if you didn't memorize this, then you can just simply calculate it, simplify it. Let's just see what will be my I theta by using computations. Let's just find out L first, that is 1 by sigma root 2 pi power n e power minus sigma xi minus theta's whole square upon 2 sigma square. As my sigma square is equals to 1, so this will go to 1. Okay, this will be 1, 2. And taking out the log L, that is equals to minus n log root 2 pi minus summation xi minus theta's whole square upon 2. Okay, and del by del theta of log L, that is equals to, this will be to go to 0, and this will be minus 2 summation xi minus theta's upon 2, and this will be minus 1. So this is mine 2's to cancel out, negative will be positive, and this is sigma xi minus n theta. Okay. Okay, let's differentiated one more time, that is del square log L by del theta square, that is equals to minus n. So I got my I theta is equals to minus expectation of minus n, that is equals to n. Okay, so what is my Kramer-Rao lower bound for g theta? That is equals to g dash theta's whole square, that is 2 theta plus 2's whole square divided by n. And what is my n? N is equals to 4, right? By 4. So I got my Kramer-Rao lower bound, which is L theta, that is equals to theta plus 1's whole square. Okay, and I can clearly see that this is my third option, so this is true. Okay, and we have to check for the false one. Okay, Okay, so my third option is true. Let's check for the another things. So we know that in the normal distribution that x bar, the thing x bar is sufficient by the factorization theorem. By factorization theorem, we can see that x bar is sufficient statistics. So by one-on-one correspondence, by one-on-one function, we see that one-on-one function, it is this, sorry, this x bar plus e's power x bar is an one-on-one function sufficient estimator of the function. Okay, so this is what x bar plus e's power x bar is one-on-one function of sufficient estimator. Okay, and my sufficient estimator is x bar. So this will also be true that x bar plus e's power x bar is sufficient statistic for theta, as x bar is sufficient for statistics for theta, and it is a one-one function of x bar, right? So this will also be true. Okay, now let's just look at this one option, that is 1 plus x bar whole square is UMVUE, that is uniformly minimum variance unbiased estimator of g theta. Okay, and for the uniformly minimum variance unbiased estimator for this function g theta, the first thing that has to be satisfied is it is saying that it is an unbiased estimator of g theta and it has the minimum variance. These are the two things that it is saying. Okay, so let's check for this one that whether it is an unbiased estimator for the theta or not. Okay, we are just simply checking its unbiasedness. So let's by checking its unbiasedness, okay, that is expectation of, well, just erase this part. Okay, and we also know that one thing, that is x bar is complete sufficient, right? X bar is a sufficient estimator that we know, and x bar is also complete sufficient. Sorry, okay, x bar is also complete sufficient. Okay, so what is the expectation of x bar? That is equals to mu. And what is variance of x bar? That is equals to, we know that it is sigma square by n. And then what will be the expectation of x bar square? That is equals to variance of x bar plus expectation of x bars whole square, that is equals to mu square. Okay, so this is the things that we got, and we have to find the unbiasedness. We are checking the unbiasedness of this, whether it is unbiased to g theta or not. Okay, so expectation of 1 plus x bars whole square is equals to expectation of 1 plus x bars whole square plus 2 x bar. Okay, so this will be equals to 1 plus expectation of x bar square plus 2x bar, that is equals to 1 plus what is expectation of x bar square, that is sigma square by n plus mu square. Okay, and what is our sigma square here? That is 1. N is equals to 4, that is 1 by 4, and mu is equals to theta. So I got 1 by 4 plus theta square, 1 by 4 plus theta square plus this will be equals to theta. This is theta, so this will be equals to expectation of x bar. Sorry, this will be equals to 2 theta. Okay, so I got 5 by 4 plus theta square plus 2 theta. Okay, so as we can see that expectation of 1 plus x bars square is unbiased estimator for this thing, that is theta square plus 2 theta plus 5 by 4. Okay, so it is not satisfying it. It is not uniformly minimum variance unbiased estimator of g theta. That is, we got expectation of 1 plus x bars whole square minus 5 by 4 is equals to g theta. Okay, so this statement is false, that it is UMVUE of g theta. Okay, and we have to check for the false statement. So this is my corresponding false statement. Okay, so if you want to also check for this part, that is variance of 1 plus x bars square is greater than equals to 1 plus theta whole square upon theta. So for checking this part, what you have to do is simply apply the Kramer lower bound, that is this part g dash theta's whole square upon I theta, and whether check for whether you are getting this result or not. Okay, I'm definitely sure that you will get this result, because it is so simple. You just have to simply calculate this thing, like doing the differentiation and all these things like we have done for the this L theta part. Okay, so my result is this is the corresponding false statement, so my option number D is false. Okay, that it is not UMVUE of G theta. Right, let's see question number 18, and this is the, I think this will be the last question for this video. Okay, so in the question number 18 we have given two series. Okay, this is my series S and this is my series T. Okay, and we have to check whether these two series are convergent or divergent. Okay, so let's check for S. We have got S like this, sigma n is equals to 0 to infinity, 258 going to this one, and upon 159 going to 4n plus 1. Okay, so whenever we got something like a series type questions in this, we have done like so many questions of these types, so let's just apply ratio test for this one. Okay, and let's see what will be the result. Okay, so for the ratio test, what we have is that limit n tend to infinity an plus 1 by an is equals to L, and if this L is less than 1, then my summation an, what will be the series here, is will converge to 0. Okay, so this is my ratio test. Then if L is less than 1, then it will converge. Okay, so I have, this is my an. Okay, this is my an. Then what will be my an plus 1? That is equals to summation, sorry, not summation. This is my an, so my an plus 1 would be 2, 5, 8, 3n plus 2 and 3n plus 1 plus 2, right? Upon 1, 5n, 4n plus 1 and 4n plus 1 plus 1, right? This is my an plus 1. Okay, okay, let's just apply ratio test, that limit n tend to infinity an plus 1, this part, that is 2, 5, 8, 3n plus 2 upon 3n plus, this will be 5 upon 159, 4n plus 1, 4n plus 5 upon, this is my an, that is 2, 5, 8, 3n plus 2 upon 159, 4n plus 1. Okay, let's just see what will cancel out. This all will cancel out to this one, and this all will cancel out to this one. And we got limit n, sorry, let's just write it here. Limit n tend to infinity 3n plus 5 upon 4n plus 5. Okay, let's just take out n common from these, and we will get 3 plus 5 by n upon 4 plus 5 by n. Okay, and we know that 1 upon infinity or any number upon infinity will go to 0. Okay, so this term will go to 0 and this term will also go to 0. So I got 3 by 4, which is less than 1. So this series would converge. Okay, right. Now let's check for the t, whether t is converging or not. Okay, so for the convergence of the t, we have t that is summation 1 plus 1 by n's power minus n square, right? So we will apply a root test here. Okay, and what is in the root test? In the root test, we have that limit n tend to infinity un's power 1 by n. If this is less than 1, if its limit L is less than 1, then it will converge. Okay, so let's just apply it here. So my un, or you can say an, is this here. Okay, so I am applying it here like limit n tend to infinity 1 plus 1 by n's power minus n square by n. Okay, and this would give me limit n tend to infinity 1 plus 1 by n's power minus n, right? And I can write this minus n like n's power minus 1, right? And you can see that this 1 plus 1 by n's power n is actually e. Oh, okay. Limit n tend to infinity 1 plus 1 by n's power n is equals to e, and we got e's power minus 1, that is equals to 1 by e. And this term would always remain less than 1. Okay, so we can say that this series 2 also converges as it is less than 1. Okay, by root test. So the correct option here is both S and T are convergent. That is option number 1. Okay. Okay, so these are just the easy questions. Some are like you just have to do one thing, that is if you're clear with the concepts, then these are not like that much hard questions. These are medium type of questions. Okay, so just clear your concepts and they are so easy for you. Okay, thank you so much for this lecture. Let's meet in the another one. Thank you.